No. Unit 5, Day 1, Scientific Notation Notes. Okay, so scientific notation, hopefully y'all dealt with scientific notation a little bit. I'm not going to lie, it does throw me off a little bit, but as long as I think about something that I'm going to make you write down here in a minute, then you should be okay. So scientific notation is written as a number between 1 and 10, multiplied by a specific power of 10. So like this is your example, 8.2, is that a number between 1 and 10? Yes, and it's multiplied by 10 to the 4th power. That's a specific power of 10. Okay? That's scientific notation. Okay, now if you'll notice, it says to change from standard form to scientific notation. Standard form just means like a regular number. 10 is technically standard form. Okay, it's just a regular number. Scientific notation is when we change that regular number, okay? So standard form is just a regular number. Okay, so it says, place a decimal point that there is one non-zero digit to the left of the decimal point. So I'm going to explain what that means. Just means there's one number to the left of decimal. Okay, another thing I want to talk about that's not typed in here is if you have the number 10, where is the decimal, at the beginning or the end? The end. Okay, if there's not a decimal, it's always to the farthest right that you'll put it. Okay? Because technically, if you put it at the beginning, wouldn't that be 0.10? 10 cents and $10 are very, very different. Okay? So if you ever have a number, it's always to the right of the numbers if there was no decimal. Yes? Okay, that's where it is if you don't see it. Okay. It says count number of decimal places that the decimal quote-unquote moved from the original number. This will be the exponent of the number 10. So how many times you move your decimal is the exponent. Okay? Yes? No. Okay, then it says if the original number was less than 1, so like look at this example right here. This number is less than 1, right? 0.00000789. Okay, then it's going to have a negative exponent. If the original number was greater than 1, like this top example, you're going to have a positive exponent. So this is an important rule to remember. Okay, so we're going to do 2 examples. Okay, so if you look at this, it's 4750000. Okay, where's my decimal if I don't see a decimal? All the way to the right. Now, where do I want my decimal to go? Huh? Between the 4 and the 7, because we want one number to the left. Doesn't that leave me one number to the left? Okay, and I don't need to write down my zeros, so that gives me 4.75. Okay? Times 10. Well, how many times do I move it? 1, 2, 3, 4, 5, 6 to the 6th power. It's a number bigger than 1, so I keep a positive 6. Any questions with that? The nice thing about when they're smaller than 1 is you know where the decimal is. It's super obvious. Okay? Now, I know that this is going to be to a negative power, so I'm going to go ahead and put the negative there so I don't forget. Where do I want the decimal to go on this one? Between the 7 and the 8. So I'm going to have 7.89, and I'm going to move it 1, 2, 3, 4 times. So it's to the negative 4 power. Any questions with that? Now, when the powers are small, the cool thing is you can check your work in the calculator and sometimes even find your answers in the calculator. So I could technically type 7.89 times 10 to the negative fourth power. Did it work? Is that what I was given originally? Yeah, so I did it right. Does that make sense? If your exponents are small enough, you can type them in your calculator. So like this one, 4.75 times 10 to the 6th power, it also shows you. And that should have been 4 zeros, which is 4 zeros, so we did it right. Okay? Any questions with that? Okay. So that was moving from a regular number to scientific notation. So now we're going to do scientific notation to standard form or regular number. Okay? We're taking it out of scientific notation. So knowing that, you'll move the decimal to the right for positive exponents. And you'll move the decimal to the left for negative exponents. Because moving it to the left is going to make it smaller than 1. Moving it to the right is going to make it bigger than 1. That's why we do that. Okay? So for example, this is times 10 to the negative 8 power. Okay, negative means smaller than 1, so which way am I going to move? To the left, because that's going to make it smaller than 1. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8 times to the left. So I get 0.00000000, which is 1, 2, 3, 4, 5, 6, 7 zeros. That's what that becomes. All the empty spaces get a 0. Any questions with that? Okay, now on this one, it says times 10 to the positive 3 power. So which way am I going to move if it's positive, bigger than 1? To the right. So 1, 2, 3. There are no empty spaces, so 5, 0, 2, 4. Any questions? Okay, so the biggest thing to remember, if you can remember what I'm about to tell you, if you have a number that's less than 1, it's going to be a negative exponent. So this goes either way. If you have a negative exponent, it's going to be a number less than 1. If you have a number less than 1, it's going to be a negative exponent. Yes? So if you have a number greater than 1, it's going to be a positive exponent. So remember, it goes both ways. Positive exponent is going to be a number greater than 1. Greater than 1 is going to be a positive exponent. Now, there are a couple on the practice that I want to talk to you about. Okay? So I'm going to let you finish writing that. And we'll go over those, and then I'm going to let y'all practice. The cool thing about this practice is it doesn't take long at all. And then you have free time to finish your exponent practice if you haven't completed those yet. Okay? So if we flip to the practice, look at number 5. Do we need to move this decimal at all? Or is it in the right spot for scientific notation? It's already in the right spot. So how many times did we move the decimal? 0. That's the correct scientific notation form. So if you ever have anything to the 0 power, what does that equal? 1, right? Anything to the 0 power is 1. So 6.7 times 1 equals 6.7. So did it work? Yeah, this is the scientific notation. Huh?
What about number 7?
We're looking at that one next. Okay, now look at number 7. I want you to realize the instructions here said write each number in scientific notation. Well, this is kind of in scientific notation, but is it correct scientific notation? No, because that's 71. How many numbers are you supposed to have to the left of your decimal? Just one. Okay? It's supposed to be 7.1, but it told me 71. So I want 7.1 to be proper standard form, or scientific notation, sorry. Ignore my decimal. Technically, it's 71 times 10 to the third power. So if I move it one more time to the left, I'm going to add 1 to that because it's a number bigger than 1, so it's still positive. Okay? Now, if that confuses you, could you have put this in standard form, 7, 1, 1, 2, 3, by moving your decimal and then rewriting it in scientific notation?
Yes.
And then realizing 1, 2, 3, 4, so it's correct. Does that make sense?
Easy.
Okay. Okay, one more. Look at number 3. How many times, well, where is my decimal? Is it before the 6 or after the 0? It's actually after the 0. If there's no decimal, it's always on the right. Okay, so that's where my decimal is. Now to put this in proper standard form, which way am I moving my decimal and how many times? How many? One time to the left. Okay, so I get 6 times 10. How many times did I move it? Once, and it was a number bigger than 1, right? 60 is bigger than 1, so it stays positive. That's it. Okay? Don't overthink these. Okay? If you want to check your work, I do have something to come check your work at my desk. Those of you online, if you want to check your work, feel free to text me. And this is what you're working on. We did number 5.